Hi everyone, I'm Ben Braun. I'm a mechanical engineering major from the College of Engineering. Today I'll be presenting our senior capstone project that I completed with my team members, Rachel Castaldi, James Escarilla, Michael Ferrugia, and Ming Lian. Together we designed and built L.I.I.S, or a lift and installer for Incubator subassemblies for our client, Rapid Microbiosystems. First, before I continue, I want to acknowledge some of the individuals listed here. First, our advisor, Professor Hauser, for his guidance and assistance throughout the project, to the team at RMB for their consistent design and material support, and to the staff at EPIC for helping us fabricate some of our components. Our project concerns the manufacturing of RMB's flagship product, which is an automated incubation system that's used for testing microbial samples in quality control labs. The nature of this product means that its internal components are both very heavy to accommodate a large volume of samples, but also very delicate to handle them properly. The system primarily consists of two units, as you see, stacked on top of each other. Inside each of these is a subassembly that is called a carousel. And it is this subassembly that we are concerned with manipulating and installing. Each carousel consists of two plates that are connected by 4 poles located roughly at the corners with internal pneumatic and robotic components. Each carousel weighs just under 200 pounds and is installed into an incubator by being linearly inserted through a manual process. Critically, though, the carousel in the upper unit has to be flipped 180 degrees prior to installation due to the nature of the manufacturing process. And our project concerns only the installation of this upper carousel. The current installation process, as performed by RMB's technicians, uses a hydraulic scissor lift cart to manipulate and help install the carousel. This process contains a number of potential safety hazards and does not adequately meet all functional requirements. It has no stability mechanism, so that means, especially when you have a carousel in a raised position, the system can easily become unstable, possibly tip and fall over. The actual bed of the cart does not rise to the appropriate height for installing the carousel, which is about 5 feet off the ground, as required by the upper incubator unit. There is no constraint mechanism that secures the carousel at any point during this process while it's being raised or maneuvered about the manufacturing facility. And most importantly, there is no mechanism that facilitates a flipping operation. Right now, that is done completely manually. Since this system deals with an industrial scale load, any error in this operation could result in potentially serious injury to any one of the technicians, or at the very least, significant damage to equipment or production delays. And so the goal for this project is to develop a scaled prototype that can demonstrate a superior functional performance and amend the major safety hazards. So after extensive benchmarking research, prototype iteration, and feasibility analysis, we came upon the image on the left as our final design, which can be broken down into major subsystems as seen on the right. We use the existing cart as the basis for our design. Since this is readily available to us, it is already proven that it's at least capable of supporting a full load capacity, and using it helps to minimize our overall prototype costs. We attach 4 outriggers on the bottom frame of the cart in order to provide a very simple stability mechanism and improve system balance. And then in gray are also assorted components that enable all of these individual subsystems to be connected to each other. The conveyor subsystem allows for more precise positioning and easier insertion of the carousel into the incubator unit. It also fully supports the load capacity and has clamping mechanisms that completely constrain the motion of the carousel. Then the flipping subsystem enables a flipping operation by raising the carousel a foot off of the build surface using 2 lead screw actuated linear stages. Once in a raised position, the flip can then occur through a manual process, but in a highly controlled manner. This subsystem is also modular, so it can be taken off and then reattached to the overall system. Due to the fact that this operation contains the most functional deficiencies and greatest safety risks, it is what I'll be focusing on for the remainder of my presentation. This is the subsystem that was scaled down, specifically to a 50-pound load capacity. All of our other components are designed for the full 200 pounds with a factor of safety of 2, making for a total load capacity of 400 pounds. I'll be focusing on some of the key components that go into this, beginning with the grippers that are shown in red. One of the earliest problems we encountered was how to actually attach onto this carousel unit. Since we have a very limited number of touch points and can really only use the exterior frame, we cannot contact any of the internal components, and we were not allowed to modify the subassembly in any way to make it easier to attach to. So we decided to select the poles since those avoided the internal components as much as possible, while also maintaining as much balance with the center of gravity of the carousel as much as we could get. From a list of 7 candidates, we performed compressive load testing using an apparatus that you can see in the upper right, and determined that the best candidate was an extra grip, extra wide shaft collar. Any one of these shaft collars can actually support a full load of 800 pounds. So this means that it is a very robust system and can easily support a full load capacity during a flipping operation. The other major component I want to touch on is the torque limiting coupler shown in orange. This is meant to restrict rotation of the carousel as it's being raised and lowered in order to preserve system balance and restrict the number of degrees of freedom in this system to 1 at any given time. There's also a thumb screw on it that allows you to loosen it in order to actually perform a flipping operation. You can see here a video that we took while we were still performing testing on our subsystems in isolation. You can also see my group member here having to steady the apparatus as it's being raised. That's because the torque limiting coupler didn't behave as robustly as we would have liked. It is supposed to remain completely static within its housing. However, it was able to remain loose and translate slightly side to side. It meant we did not keep our rotation underneath the 1 degree benchmark that we had set for ourselves. However, aside from this issue, which became a subject of future work for us, the overall system still performed effectively and was able to function with a 50-pound load. And you can see on the left image a fully assembled version of our prototype in our manufacturer's facility. And then this video shows an actual installation operation. You'll see 2 of R&B's technicians install a partially assembled carousel into one of the incubator units. You can see also the red handles that are the clamping mechanisms that completely constrain the motion of the carousel. And when we took this into our manufacturer's facility, we demonstrated all of our prototype, and we presented a lengthy design review to them. And the response that we got back from all of the stakeholders was extremely positive. They were very satisfied, as you can see them getting the positioning right now, because there are rails that have to slide in a specific way in this installation. Their feedback was very positive in that they believed that we had very significantly improved the functionality over their previous device, and that we had mitigated a number of the major safety concerns. And you can see then the installation be complete. Since we completed our scaled prototype pretty early in April, we were able to go a little bit beyond our initial scope for this project and begin the actual development and construction of a full-scale iteration that they approved the funding for following our design review. You can see a roughly 75-ish complete version, 75%-ish complete version on the right-hand side. And this we were able to perform some light testing on. We were able to perform a full flipping operation, and it was more robust than our scaled version. We also promised that we would develop individual deliverables, such as bills of materials, engineering drawings, and all documentation that would be needed to construct as many of these devices in the future as possible. We also performed some other light adjustments to our outrigger bracket geometry to make them more ergonomic to remove and then reattach to the bottom of the cart. And we also adjusted our torque limitation method. We devised a new solution that can use a motor with a worm gear mechanism in order to restrict rotation, and this also gives us the advantage of being able to fully automate this flipping process. So now no manual input will be required at any point, and this makes the system overall safer compared to our scaled down version. And so that concludes my presentation, and I'll take any questions.
That was a really interesting presentation. Can you talk a little bit about your interaction with the manufacturer and maybe some of the key pieces of feedback that you got that impacted your design at the end of the day?
Yeah, so we had 2 engineers, a manufacturing engineer and a mechanical engineer, assigned to us pretty early in the project. We would meet with them weekly to discuss design updates and propose different ideas. And then we also took multiple trips to their manufacturing site, which is in Lowell, Mass. And we would speak there to the actual technicians who were responsible for actually assembling everything and putting this together. And we got a lot of really invaluable feedback from them. And a big part of our demonstration was not only having us do it, because we're of course very familiar with this product, we can do all of this relatively easily, but also making sure that it's relatively user-friendly and that they can perform the process easily as well. And so they found that they were able to do that successfully and express, a great deal of they like the project a lot.
Working with an outside client, did you have any financial constraints for your design, or how did that work?
Yeah, so really the overall guiding principle of this project was worker safety. So that meant that as far as cost was concerned, how much are you willing to pay to ensure worker safety? So budget was never as serious of a constraint for us as it was for a lot of other engineering projects. And so that gave us a little bit of freedom, especially developing it in the beginning. And of course, they took over all of the funding once we had given our design review. But just for some perspective on cost, combined with the existing cart and all of our modifications, any one of these devices will cost about $2,700. And implementing this, and I think the plan is currently to do 4 of these devices, is about 11,000 or so. So for them, this is a more than acceptable figure for improving safety for their technicians.
Ben, it seems like this is like a kind of elegantly low tech, like in a good way, if I'm reading it right, solution to a very, like a highly precise and innovative context of the client.
Mm.
And I wonder if you could like just say a little bit about anything you learned from kind of just a process of putting something together from basic parts. It seems like it's a sophisticated problem in a sophisticated context, and like what's the role of this kind of work in kind of the world of technology and like worker safety for like the type of like high tech innovations that might be more flashy in like common parlance.
Yeah, so some industrial technology, some of it can be flashy. A lot of it is very mechanical heavy and simple, a lot like this. This is not the most complicated system in the world. Even the electronic components are relatively straightforward. But to speak more to your point about like learning through this process, you can see this is what our final design was. A much earlier version of this consisted only of one of these lift columns, because from a lot of the products we had benchmarked, a lot of these were able to perform operations with similar loads using only one of these. We thought we would be able to achieve this as well. When we did that and performed a lot of feasibility testing with that, it didn't work. It failed pretty badly, actually. And so we were very able to quickly pivot to this new idea of using 2 to counteract any kind of dangerous moment we would experience with this weight. But that was mainly the process of just developing this new mechanical system, yeah.
Can you talk a little bit about the clamping mechanism? Specifically, like,
Yeah.
how do you make sure that it's not going to slip out? And maybe any other applications you see for this system in different environments or manufacturing settings?
Yeah. First, on the different applications point, this is pretty hyper-specific. The reason why they needed a new device and couldn't just go to some normal industrial supplier and buy something was because of the specific nature of what they're dealing with. So this is probably not a system that you're going to see become widely used in any way. But in terms of the actual clamps, it's not a terribly complicated system. We have an adjustable positioning mechanism that allows you to move them along. Really, right now, it's just some 80-20 like runners that just run along the sides. This allows you to avoid any of the components that are on the plates, because one of the other complications is that this is also a work surface. They build this entire thing on the cart. So this also means they have to be able to rotate it and clamp in different locations as they add more components to the bottoms of these plates. And so that was really just the main concern, was making sure we could move this around sufficiently. And then it just clamps down. Basically, we just made sure that our tolerances were very good, that we could get a tight clamp, and it's tipped in rubber, so it's not going to permit any sliding.
Thank you very much.